Hello, there is Fimpossible Games and welcome to Fimpossible rigging tutorial. It will be a bit longer video than others, because we will do some programming, not just setting up components. I will show you what to do to make model move like here. From this to this. Then show you how to program things like here, so dragon backs up head to not hit surface, few other polishing stuff, and flying. We will use here just simple calculations to do this, but I hope it will be useful for you. So let's get started. First let's put dragon on a scene. It's model made by Protofactor, and links you will find in description of this video. I will use ground feeder to control movement of this creature, so I'm setting up components to make model move on uneven terrain good enough. I will match collision detection area to the model, making it a bit more precise. This component is controlling rotation on uneven surfaces, so we will have nice motion to test all of stuff we need. Rotation component is set, so let's add movement component. But later in this tutorial we will make custom movement, so we will make script which inherits from ground feeder movement, and then we will extend it for our likes. Let's name it Fimpossible Dragon. Open it in Visual Studio. Let's clean up it a little. We don't need this now. Let's inherit from ground feeder movement, but it's in different namespace. So let's write ground feeder, press Ctrl plus dot, and Visual Studio will find namespace for us. So let's select ground feeder movement, but let's use ground feeder movement look, cause later we will use look animator, and this class have inside some stuff done to support this. You can click on class name, hit function key 12 to go to class definition. So our class will do the same stuff like these two classes, but we will extend it a little for our needs. So variables we set in inspector now will be kept when we extend it. Wait for compilation, and let's add our component. There it is. We will set these variables in play mode, but let's now add input controller, so we will control the creature. Whoa, I almost forgot. I must set ground layer mask. In last test version of ground feeder there should be default layer set when you add component, but I have here previous version. Okay, now let's set up animator. Ground feeder movement is using clip names like idle, run and walk. So we must change this clip name states, and in this tutorial we will use clips without root motion. I will show you how I setting movement speed during play mode. Now let's set camera target. I'm using here components from FBasic assets, which is my free tools package. I have already here set some variables, so camera will follow dragon correctly. And thanks to ground feeder and ground feeder movement, we can walk. Now adjust movement speed to the animation. So let's try to go to correct values. Make it match as it possible. Just trying to find this sweet spot. And I think that's correct enough. Now let's set sprinting speed, and it should be a bit faster. Yeah, let's copy the settings in play mode, then paste in edit mode, so we have everything remembered. Now let's enhance this animation a little. Let's add float value. It's animation speed, and this parameter is used by ground feeder movement to control animation speed for movement clips. So we apply this parameter as multiplier for animation speed in host animation clips. And now you can see that this adds a lot to animation. To get better result we should run stopping animation, but if we don't have it, we can do something like that and see the comparison. Okay, when we have this, we are ready to add spine animator. So let's find it. Thanks to that component, dragon's spine will follow movement of the game object. We must find pelvis bone, and it's here. There is tail, which we will use later, but now we must define last bone in spine chain, and it will be neck. Here you can see how spine chain looks. Let's click auto in basic correction options, so component will do some stuff for us, and check how it looks. So spine animator works correctly, but we must do some tweaks for it. But I think we will do tweaks later. Now let's add the spine animator to tail. Adding spine animator to work with tail is tricky. Sometimes you should add spine animator to root game object, but in this situation we will add it directly to tailbone. And here you see that leading bone is in the wrong place, we should change it. It should be at the beginning of the chain. Let's also click on auto button. Then tail should be updated after spine motion, so when we move spine, the tail is in the right position in order to spine procedural animation. Q to last update will do it for us. Then we must set anchor reference point for tail bone. It will help leading bone to keep right coordinates. So now it looks like that, but we will tweak this. Don't worry about this red message, it's just to detect if something wrong is going on. Our tail is very long, so algorithm misinterpreted this. Okay, now there will be important tweaks for tail. Go back speed variable is doing very good job here. As you can see, now it works much better and is following all motion precisely. Let's jump and let's move around a bit. Here I change little, but very important variable, which is rotate to target speed. It's just changing how fast model is rotating to target rotation. When this rotation is slower, animation gets just much more mass to it. Also you can check how main pivot offset variable is working. Okay, we will do more tweaks later, but now let's add look animator. We will have better reference to set whole model motion. So let's get head bone, it's correct. Let's assign object to follow, and now we will use this inheritance which we did before. So at the bottom of FImpossibleDragon we have variable from ground feature movement look. It will move follow target game object in desired direction of movement. Let's set up look animator a bit, add backbones, adjust it a little, set clamping ranges fitting more for dragon character, okay, and something more, no, rest in play mode. And you see it works, but it needs some adjustments. Here I would like to use other fixing preset for skeleton hierarchy. Let's select this, it's for characters made in 3ds Max. And let's offset head a little. Okay. And here you see that neck have different shape than in original animation. Let's fix it. And now it works just fine. Yeah, this head animation is giving another big boost in animation. So when we move and rotate camera, the neck is rotating to the desired direction, giving nice feeling to the motion. So look animator is set up, so let's copy settings from play mode, then paste in edit mode so everything is remembered. What more we can do? Yes, we have wings and we can add some elasticity to them. And for that we will use tail animator. Select wings, add tail animator blending for animated bones, and hit connect with animator. Disable waving, and let's see how it looks. Yeah, one wing looks weird, that's because connect with animator button not works with multiple editing. And you see it adds more smoothness, but you see these fingers are bugging out, so let's fix this. We probably will need to use less bones, so let's check how the hierarchy looks. You can see in gizmos where are bones. We will exclude these two last ones, so we will use 3 bones. Let's check if I am correct. Yeah, we don't need these bones. When we go enchain to this, it will be good. So let's remove these 2 bones and do the same for second wing. Let's hit play and check how it looks now. Yeah, now it's not bugging out. It's a bit gentle effect. Let me show you how it looks when we disable tail animators. Let's enable it and then it looks like that. We can make this effect more noticeable, but I like to use it in decent amount. We can customize it more with blending and other variables. Setting position speed and rotation speed higher will make wings more stiff. So I guess you should tweak it for your likes. Now you can notice loop frame in idle animation. We can enhance this animation a little using waving, but let's make it more randomized and milder, slower and lower range. It helps a little to mask animation loop seams. So let's move around with these settings and check how it looks. Yeah, it looks nice. Let's go on terrain and let's move on hills. Oh, dragon started to falling because big slope. I will change fitting speed in ground fitter, so it's matching to ground quicker. But let's add some total smoother variable, so rotating game object will be smooth anyway. Okay, I think setting up basic components are done, and first part of this tutorial is finished. Now we will enter coding area to enhance this controller more. So let's open our FImpossibleDragon script. First thing we will do will be smoothing out changing position for look animator target object. Simple thing just for warm up. Let's make this method virtual, so we can override it in our class. To smooth translation of this game object, we need to remember target position. And instead of setting immediately position of transform, we will do it in update method. So let's define variable target look position, and when parent script is running setLookAtPosition method, we will just remember this target position. Now let's override update. So if we defined target object, we changing this position smoothly using lerp from current position vector to remembered target, and defining speed of this. That should be enough. Check if it works. Let's see it in scene window. There is our target. Let's hold F button to focus on object hard, and it works. So look animator can benefit a bit with that. Now let's make dragon back off head when there is obstacle in front of him. But first let's show me what we will use for that. Let's say dragon is standing like that. Then there is in look animator variable in correct and rotation called backbones at offset. But use here decent values because it just flips off when we use it too much. So we will go to 90 from -70. Okay, -70 to 90. Just to remember what values. Now we need to know which look animator needs to be changed. So let's write class name, control dot so namespace is imported. We will call this variable look, and let's override start method. Let's get reference to look animator, and then we can go to more advanced stuff. We will smooth change this variable from look animator, so let's define it. And what was the name of this variable? Backbones at offset. So let's name it target backbones offset. Let's set default value for this, and it will be the same like in look animator. And remember, we're using z-axis. And how we will detect what is in front of dragon? We will use raycast. And first let me show you how we will use it. So we must check if something is in this line, but sometimes obstacle can be very near head, and it will be safer to cast raycast from last backbone, and it will be this bone. So we will check in this line. So first let's define a raycast variable. Now let's define array, and we will start from backbone, so we need to go to look animator, and we have list of backbones transforms, and we will use look animator backbones count -1, so we get last bone. And direction of the ray will be transform forward, so direction which dragon is facing. Now let's do physics raycast. Use our array. What max distance should be? Let's check in scene window. Let's create just empty object, and so we can reference. And z is minus 20, let's go. It's minus... We should check to this place. Minus 12, minus 6, I think 6 will be enough. So let's put it here. Now let's define layer mask, so we hit only objects we define. Look, layer mask. Let's set it will be default layer, so we don't have to change it anyway. Let's set result output variable look hit. It's wrong place, let's move it. Yeah, it's right. Let's do brackets for look hit something, or in other situation. Else. And if we hit something, we will check distance between position of hit and to ray starting point. Then we will have possibility to change this back neck variable progressively when we go nearer to the obstacle. So we go from minus 70 to 90 with lerp, and let's define the distance. And we have origin to hit point. Then let's use math inverse lerp, so we get like percent value between two values. And it will be minimum distance to maximum distance, so from 3 to 6. And here our distance. Wait a minute. It would be reversed. Let's change these values from 6 to 3, then it will go in right way. And then when we not hit anything, then we will go to default value, so minus 70. But we should make this variable change smoothly, so let's change the name, not current but smooth, backbones offset, control dot, and everything is changed. Now let's do the same what we did with target look position changing. So let's use lerp to change this value. Let's make speed, and I think it should be slower. Then the same for going back to default value. Current, target, and let's make it a bit slower. Yeah. Then finally let's change this value inside look animator. Let's set new vector 0, 0 and our value. Let's save and let's go and see if it works. Hit play. And let's go near to the obstacle. And as you see, it's working. Just gives more life to the model. But doing it that way will give some troubles in situations like that. We set the raycast direction to go forward, so it goes this way. But it should go always flat. Or we can put here direction to target look object. But we will use something more interesting. Ground fitter is holding this flat rotation value, and we will use it here. And we go quaternion Euler 0, then y-axis will be this what we need. And this will be ground fitter. Since we are inheriting from ground fitter movement, we have reference to fitter. And it was variable, it was rotation y-axis. And then 0, and we multiply this quaternion by vector 3 forward, and it results in direction vector in the rotation we provide. So let's check if it works. Let's go again. And yeah, everything works fine. And what we should do next? Notice that when we jump, the spine is freezed in this position. To repair this, we can go to spine animator and use go back speed variable. It's constantly straightening spine, so when we move it steals some bending, but it's helping making landing look right. So we will change this variable for a while when we hitting ground. Let's tidy up this code a bit, because we will not need this code anymore. We don't need to see it, so we put it in region. And the same for the variables. They are not needed anymore here for us, but they should exist, but we don't have to see them. So everything is clear now. Let's start doing next thing. We need reference to spine animator, so Ctrl dot and we have namespace. Let's call it just spine. Let's get it in start. And now let's override method for hitting ground. Then for straightening we will use coroutine. So let's define enumerator. And again Ctrl dot, we have this imported. And let's name this coroutine straighten spine. We will use this enumerator as instantaneous update loop. So we smoothly change go back speed variable to, let's say, 0.55 in speed times 5 should be good, and do it in while loop, and our condition will be doing this stuff until this variable is lower than 0.5, not 55, because lerp is never reaching the target value. Yeah, the most important thing, yield return null. So it will wait frame, then do this while again. And after reaching this go back speed value, we go back to 0. So let's lerp it to minus 0.05, that should be good. And then after all of that we setting go back speed back to 0. So I save, wait for compile and check how it looks. Yeah, everything is working. I think we should do the same when we start jumping, but let's save it for you. Okay, now we can start preparing for flying. Let's check what animations we have. So take off to fly stationary. Yeah, I think I can use this. When we're starting to fly we will smoothly transition to this, but let's start from different frame, because we will use crossfade. And we will do it in the way that we not taking control of movement from player. So I'm choosing frames, which I feel will look right with my approach. Let's bake all of that, so nothing interfere with the positions. Yeah, I think it should work right. This model don't have jumping animations, but I will try to make some from other animation. Let's see how looks take off to glide. Maybe it will... no, take off, jump up we will say. Let's see how it looks. Okay. Yeah, when it starts moving up, then let's say here. Something like that. Let's bake again. Okay. Now let's make loop variant of this animation. Dragon jump up loop. This animation speed value will be multiplied by low value, so we just only need few frames, nothing more. And let's find animation for pose to falling down. No, that will not work. Stationary to landing. No, it's not what we need. We're falling on front legs. I think run is only choice here. So fall to landing. And let's find these frames. Probably somewhere in here. Yeah, let's loop and let's adjust this loop and let's bake so we see preview correctly. Yeah, it will be very slow animation, so we don't need too much focus on here. Okay, now let's add this clip states. We name it with dragon so we easily find them. Jump up, then jump up loop. Let's do transition to it. Okay, let's adjust it a little. To be honest, I don't like using this stuff. I like more using just crossfade from code. I see I have to adjust loop animation a bit. Okay. Okay, that should be enough, yeah. Let's multiply this animation speed. Okay. But let's also speed up jump up animation. A little more. Yeah, I think it will give some better feeling when we doing it in play mode. Add clip for landing. Fall to landing. We will use this clip state names in code later. Let's multiply animation speed. And last state to fly. But later we will need to do some more clips for flying. So let's add animation clip names. Ground feeder movement have special class for it. We put in here state names, and later when we are crossfading animations from code, it will use animation state hash, so it will work a little bit more optimal. Now we will need to override some methods. Let's click here and hit function key 12, and let's copy all this stuff because we will do our calculations. So let's paste everything, and we will do different stuff when we are in air. Let's erase this, and this, we don't need that. So when we will be in air, we crossfading to, let's say, jump, fall to landing. But only when y velocity is lower than -3. Y velocity is variable from ground feeder movement, so if you want to know more variables, check root class. Let's change duration of the crossfading. And then we will override jump method, and we will add our jumping animation here. So let's crossfade to jump up. Let's make the duration half of the second. And now it looks like that. Not bad. We don't have any dedicated animation for jumping, so. But take a look how wings are moving. It looks buggy, and it's not from animation. I think it's by tail animator. Yeah. It's not handling everything perfectly. So we will have to use blending. Yeah, and then it will work right. So we will do some coding for it. First we need references to these wings. And we will create list. Again, using control dot is importing all namespaces we need. And let's use tail animator blending, because here we will access to the variables of blending. Let's find them, and here I will use method from helper class from FBasic assets package. It will be find components in all children. And we putting here tail animator blending, and inside our transform. I could make references to these wings are public, but I would like to use it like that. So all the time when we are in air, we will blend these wings to the source animation. Again using lerp to value 0.7 and delta time times 4. Then, if we are standing on ground, we will blend it back to 0. And let's check how this code works. As you see, everything is now fixed. Great. Now finally we can start making flying logics. It will be much simpler than you think. First, let's find lacking animations. Flying animations. Yeah, there is glide. And it's something like that. We will use that. Then fly stationary. We will need that. And fly normal. Yeah. Something more? No. Let's add these animation clips to our list. Fly stationary, glide, and fly normal. Let's define variable to switch between flying and walking on ground, and it's just flying variable. We will enter flying mode by double-clicking space button, and we will do it in the simplest way, so we're just making timer, subliming it every frame, and inside jump method we are checking if it's more than 0. We will set new method for start flying, and we will execute it when we double click jump. At the end we set double click timer to, let's say, half. That should be enough. Then inside start flying we setting fly true. We also need to crossfade to new animation, and what the name was? To fly. Let's paste it, and now we need to handle gravity in a different way than ground feeder movement is doing that. So if we're not flying, we do parent class calculations for gravity, and in the other way we do hours. Then we override handle transforming, and we do the same. If we're not flying, we handle transforming, and the other way we're doing our calculations. There we will do calculations which are separated from the ground feeder, so we disable it. We set in error as true. We must define variable which will hold our new rotation. It will be target fly rotation. And when we fly, we will rotate to camera rotation. Then when we move forward, we must calculate some acceleration stuff, so we copy code from the parent class, which handles it. It's that stuff. Let's paste it here. And let's modify it a little. Let's make flying speed much faster. Acceleration and deceleration speed slower by half. Yeah, adjust it a little more. Let's say this. If we are not pressing to move forward, we slowing down. And this deceleration speed will be very slow, to give more feeling of floating in air. Adding some simple statement to make clear that we are staying still. Now let's change the rotation of our transform, so let's smoothly change rotation to target look rotation. Then let's change position, and we will move just forward with a acceleration speed. And the ground feeder movement have own delta variable, so let's use it here. Okay, let's see how it looks now. It obviously isn't finished, but let's see. Okay, what we did is working, but we have to do handling animations and landing and other stuff. So let's do this. First thing to do will be handling animations. So if we are not flying, we're doing the same stuff which we are doing to this time. But when we are flying, we're doing other things. And we will do it this way, that when we are moving forward, we're running other animations, then when we are stopping, we're doing other animations. Let's copy our flying clips, so we have everything here. Let's comment that. Okay. So when we move forward, I think we will only crossfade to fly normal. Since deceleration speed is very slow, we can use all these 3 clips when we are stopping. So let's say when active speed is larger than sprinting speed, Remember that when we are flying, active speed is going to multiply sprint speed value. We will crossfade to glide. Then if active speed is larger than base speed, we will crossfade to fly normal, and in the other way we will crossfade to fly stationary. So it will seem that Dragon is just stopping when we are flying very slow. When I was flying there, I lacked something. When we were flying and trying to fly forward, we were going down because of our perspective. Then we will fly in camera rotation, but rotated in x-axis by 50 degrees up. So our direction of flying will go a little bit up. Then also when we press key left and right, we should fly left and right. So I will use here variable provided by ground feeder movement, and it just gives the rotation offset in degrees and z-axis without changes. Then we must change looking position for look animator when we are flying. So let's copy this, paste in here, delete this, and we will set it higher. Then we have to change a little bit variables in camera controller. I don't remember full names, so I go through namespaces. And yeah, now we can delete this control dot and we have everything. Let's get reference to third-person camera behavior. Now I will check what we have to change. It will be following offset y-axis, but how much? Yeah, this value would be nice, so let's program it. If we are flying, we're changing this variable in y-axis smoothly using lerp and multiply it by 2. Then if we are not flying, we're changing this variable back to normal. It's 1.8. When I was testing now, I think this should be higher. Let's add one more thing. When we are flying and not moving forward, we will straightening up spine, and if we are stopping, we will go back to 0. Again smoothly. And let's also use animation speed multiplier variable. Let's tidy up these clips we are using. Toggle animation speed multiplier. And let's change it a bit in code. So when we are not flying, calculation of animation speed parameter will be done like before, but during flight let's do it in another way. So when we are flying faster, animation of wings will be faster too. We will limit the speed of animation multiplier from 1 to, let's say, 1.8. We are using active speed divided by sprinting speed, and as you remember during flight, we are reaching multiplied sprinting speed value. And I noticed that we should change the look position. It should be camera forward position, so that should work better. We will add some extra controls, just in quick. When we will hold key left control, we will decelerate quicker, and when we hold space key, we will just fly up in a certain speed. So we decelerate smoothly, but much more quicker. Then we will need value for vertical speed, but let's define it in here. And it will be vertical fly speed variable. So when we hold key W, not space, then we change vertical fly speed to something like 1 and speed like that. That should be enough. Then when we press Z, we will go down. Just quick stuff to control this. And when we're not holding any of this key, we just go to 0 times 3. Okay, now let's use this variable. So we change position of our transform in up axis by vertical fly speed times delta. But delta is very small, so let's multiply it by maybe 20. Now let's see how it works. Let's go. Yeah, finally. And everything seems to work, right? Up, down, forward, sprinting. Yeah, but control key is very sensitive. We'll change it later. And also, when we are using sprint, I think the animation speed of wings is a little bit too fast. Now we can see how animation speed parameter is changing. I think we have to adjust it a little. First let's change sensitivity for control key, then change a bit how animation speed parameter is calculated. We will divide it by higher value, so animation speed will be changed in smaller rate. And now we will do quick way to implement landing on the ground. Inside handle gravity we will just do raycast, and it will be raycast which would be done by ground fitter. So if this raycast hits something, then we check difference in y-axis between hitting point and our position. Let's say if it's smaller than 0.25. What did I do wrong here? Y. Okay. We do here some stuff to resume ground fitter to work again. We have here method from ground fitter movement. We must provide here right raycast. Whoa. What have I done here? There should be flying variable, not in air. Okay, let's check if I did it somewhere else. No, I think now it's all okay. So let's try it. Okay, let's fly. Okay, and when we are landing, you see, we have to do few more things. When we are starting flying, we have different rotation for fitter and different velocity. We must adjust it when we are landing. So our y velocity will be active speed times our movement direction in y-axis. Yeah. And we must adjust rotation for ground fitter. So it will be our rotation in y-axis. I'm thinking if in fitter is some variable for holding rotation to smooth change, and if we should change it too. But let's see how it looks now. Let's try landing again. Okay, fly and go down. Yeah, now it looks nice. Okay. But when we try to fly forward, ground is detected immediately and we are landing. So let's fix that. When we start flying, we will do something like boost in vertical axis. So we will go up for a while. Let's do it in defined time in seconds. So let's define variable for time. And while time is lower than, let's say, 1.5 seconds, every time we wait 1 frame, then change transform position of our transform in y-axis by delta times 50. Maybe. Now when we have start flying, we start coroutine of start fly boost. And it can be useful for us to know when it's done, so let's make a variable start fly boosting. Let's set it true when we start boosting, false when we end. So now quickly let's not allow checking landing ground raycast when we are boosting. And wait, I forgot about very important thing. When we are in while, we must change time by delta time. It wouldn't work without that. And now I think we should change it to 1 second anyway. And you know what? I will change something more. When we start boosting, we forbidden changing animations. So our start fly animation will be executed fully. Okay, it went too high. Let's change it to lower value and let's change speed a bit lower. Let's see how it looks now. Okay, it looks nice. Let's check how this motion works. Let's fly here and here. Let's use the acceleration. Yeah. Go down, go up. And let's land. Oh, you see there is something going on with rotations when we go straight down to the ground. I think we should do some like raycast, checking how far we are from the ground surface. So we straightening up to flat rotation when we are nearer to the surface. Or maybe we just have to change this rotation in ground feeder when we are landing and making this raycast from ground feeder. But I think it's all for this tutorial. It was long one, but I hope it will help you a bit. So we finished in controller looking like that. You see that there is no much magic, just some components and some simple coding. Let me know if you have any questions. Check video description for some links to packages and other stuff. Like and subscribe if you want more of this content. Thank you for watching and see you next time. Bye!